Have you ever counted the number of petals on a flower? If you started counting them on a flower whose petals are all intact, you'd most likely notice that the number of petals is a Fibonacci number. That is, a number from Fibonacci sequence. Many flowers have 3, 5, 8, 13, 21 or more petals. Number of petals in a flower consistently follows the Fibonacci sequence. For example, lily have 3 petals, buttercups have 5 petals, chicories have 21 petals, and daiseries have 34 petals, and so on. These flowers that I found in our garden, named Bougainvillea and Gomamela, follow the roots of Fibonacci sequence for the fact that it has 3 petals and 5 petals, which is part of the Fibonacci numbers. This fruit that I found in our house, which is orange, is also a Fibonacci number. Let's see. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Amazing, right? Cause it all composed of Fibonacci number which follows the Fibonacci sequence. So orange is Fibonacci numbers. I also found apple here. So we will find out if it is composed also with Fibonacci numbers. Ta-da! Let's count. 1, 2, 3, 4, 5. 5 is a Fibonacci numbers. Let's eat. Next is this bandana. So let's see if it also composed of Fibonacci numbers. Wow! You see there? Let's count. 1, 2, 3. Cutie pie. But this banana is composed of 3 numbers, which is also a Fibonacci numbers. This medicine is also follow the roots of Fibonacci sequence for the fact that it is composed of 1 tablet, 2 tablet, and 10 tablet, which is part of the Fibonacci numbers. Amazing, right? Yeah. We have 2 hands and both of which have 5 fingers, and each fingers is divided into 3 parts, 1, 2, 3, and all of these are Fibonacci numbers. So what is Fibonacci sequence anyway, and why it's seemingly everywhere? So Fibonacci sequence is a series of numbers in which a given number is the addition of 2 numbers before it. So, like for example, if we will start with 0, that next number will be followed by 1, will be followed by 1, will be followed by 2, by 3, by 5, and so on. So, 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 3 is 5. So, that is Fibonacci sequence. Fibonacci sequence as a starting point of life. As you may have guessed by the curve in the box example above, shells follow the progressive proportional increase of Fibonacci sequence. Shells are probably the most famous example of the sequence because the lines are very clean and clear to see. This pepper has grown into a Fibonacci spiral. Romansky broccoli is a striking example of the Fibonacci. Each knob is a Fibonacci spiral of its own. Aloe plant, spiral aloe. Numerous cactus display the Fibonacci spiral. You can see how each set of leaves spiral outward. Fibonacci and armor equals very safe. The pangolin is able to protect its soft underbelly by forming a Fibonacci spiral. Chameleon tail, the tail of these creatures naturally curls into a Fibonacci spiral. All pine cones display a Fibonacci sequence. The ombo on pine cones increases in size as you move outward, displaying a Fibonacci spiral. Water falls into the shape of a Fibonacci sequence during humorous events. Another example would be a vortex. Fibonacci and the Great Wave of Kanagawa. It seems even famous art can escape the Fibonacci sequence. One vlogger has applied the Fibonacci sequence to population density and land mass. In Africa, the majority of highly populated cities fall on or close to where the spiral predicts. A shell fossil with a Fibonacci sequence. You can see as the shell grew, a Fibonacci spiral was formed. Yes, you are an example of the beauty of the Fibonacci sequence. The human body has various representations of the Fibonacci sequence proportions, from your face to your ear to your hands and beyond. An ocean wave is another example of a Fibonacci sequence. By the ocean floor, the wave is larger and not as close together. But by the time the top of the wave is reached, the wave is curled and is closer together. Just like the number in the sequences get smaller as you get closer to the middle of the swirl. Suppose you have two quantities, A and R, where E is greater than R. Now, add E and R and divide the sum by E. And if this ratio comes out to be equal to the ratio of E and R, then you'd say E and R have golden ratio, which represented by the Greek letter pi. You'll find examples and manifestations of golden ratio and golden spirals in countless places in our everyday life. Seashells are one of the common examples of the golden spiral in nature. Ocean waves, hurricanes, flower buds, snail shells, spider webs are some of many natural occurring examples. Many artists use the golden ratio or spiral in their creative works. Legendary painter Salvador Dali explicitly used the ratio in his masterpiece, The Sacrament of the Last Supper. From snail shells to flowers, from bananas, from inside of the human ear, from large iconic buildings to galaxies, the golden ratio can be seen everywhere. This is probably why it's also known as the divine proportion. There are so many places where we can find golden ratios on the Fibonacci numbers, but it is impossible to list all of them in one place and be done with it, because all the list is ever growing. So this is the end of our video. I hope that you've learned something, and thank you for joining me and exploring the different golden ratios and Fibonacci sequence in our natures. See you again on our next vlog. Annyeong! Bye-bye! Arigatou gozaimasu!